My name is Scott Friedman. I'm a senior program manager here at Toyota, responsible for the Project Portal, our heavy-duty truck
Awesome.
powertrain system.
Project Portal. So we just missed the truck. I mean, I got some clips of it driving out, but that's I guess specifically a partnership with them for that one. But this is basically like a rolling buck that you can sell to whoever, I guess.
So we're developing a powertrain kit that we can sell to any truck OEM that wants to electrify their fleet. So it's a kind of a plug-and-play option that we give to virtually any Class 8 tractor company that wants to take their diesel setup and turn it into a fuel cell electric powertrain. So
super cool.
We're able to package in similar locations. For example, we have our dual fuel cell stack module here that it's built in Kentucky, assembled in Kentucky with various components. We have air cleaner boxes, we have a single point interface for cooling, we have a single point interface for hydrogen, we have a single point interface with our electronics as well, high voltage and so on. That's paired with our high voltage battery pack. So essentially, if you think about it, 2 fuel cell stacks with two strings instead of a battery pack, so in parallel, matched with some hydrogen going to the electric drivetrain.
So how many kilograms of hydrogen are we talking on this?
So these are 6 10-kilogram tanks.
Okay.
So 60 kilograms. Roughly gives us a range of between 350 450 miles at 82,000 pound combined weight. So it could definitely haul, and we kind of put it through its paces.
Nice. And then what size batteries are you guys using? Do you know?
So on this one, we actually have a 200 kilowatt hour battery pack.
Okay.
It's 2 100 kilowatt hour strings.
Yep.
So we think that that's kind of right around the right area to have. Kind of on the lighter weight side, it's about maybe a quarter of what you normally see on a traditional BEV tractor. But then it allows for kind of high loads, like going up a steep grade like Grapevine in California, or coming down from a regen perspective. So we think it's kind of that happy medium for what we have in terms of power coming out of the fuel cells.
Okay, yeah, I'm curious what customers or questions you get as far as like people who are comparing this to a battery electric. I mean, obviously lighter weight from the batteries. And then the same as far as like this versus a diesel truck. What are the big call-outs you say, other than obviously the emissions difference?
Right, so the emissions difference is huge, right?
Yeah.
Especially now in the state of California, things are changing. We definitely look at the traditional kind of KPIs, key performance indicators of what tractor companies are looking for. So you're looking at total cost of ownership, freight efficiency, how many pounds you're moving per mile per dollar, those types of things. So really we're looking at trying to create not only a green option, being a fuel cell electric, but we're looking at how do we make it the most fuel efficient? How do we make it the most efficient in general? Can it do the routes and duty cycles that all these other freight operators and so on want to run? Is it just in the port area? Is it out to Ontario and Inland Empire area? Is it cross country? Those types of things are all kind of considered in terms of when we're doing our design and development.
Makes sense.
Yeah.
And obviously a lot of hydrogen stations are in California.
Sure.
And I guess, do you see much of a plan for like what the cross-country routing would look like? I mean, kind of like with battery electric, we've seen it very gradually growing out, and like, you know, major highways first.
I mean, if you think about it, Class 8 heavy-duty trucks is kind of an interesting situation, right? Because you have known routes that fleet operators run daily. You have some point A to point A, kind of back out and back type of routes that you can really pinpoint and strategically place stations in the future. So if the demand is there, then the supply will be there. You kind of look and see, okay, where are the key areas? So I think you'll be able to see tomorrow, like the Trigen facility and that kind of situation out there. So we're trying to work with kind of 2 main customers, right? We're looking at the truck OEM that's going to buy this kit and integrate it into their trucks and sell it, but really also their customers, the end users, the drivers, the freight operators. What are their needs? So we have to kind of all take that into consideration and try to marry the two.
Awesome. Yeah,
for sure.
Super cool rig. I mean, it's cool to see the underside of it too, and hopefully I'll get to go ride in the actual coated one too.
Definitely enjoy it. It's running out there right now.
Awesome. Okay, leaving that main floor back to this super cool room, and I've got, what's your name?
I'm Janice.
Janice?
I'm a senior principal engineer with Toyota.
Awesome. And you are going to show me what is probably one of the coolest dynos I've ever seen.
I think it is. So what we have here is a test setup that we use for the development of the Class 8 trucks.
Okay.
So this is the kind of engine, so dual fuel cell stack coming out of the Mirai. This is the unit that's now being produced at our plant in Kentucky. And this test bench allows us to do development that we would do in the vehicle, but in a static setup. That, you know, we can do a lot of changes very quick. No need to drive out, no need to, you know, have drivers, anything. We can do it all in the same room.
Nice. So just simulate as much as you want, basically.
That's right. This is a big simulator with the actual hardware. So what we have here, again, same dual fuel cell stack. In our case, we're connected to the radiator. That's the same as in the vehicle. We have a big giant fan that simulates vehicle speed.
Yep.
As the output of the fuel cell, we have electrical power that goes to this junction box. And that connects to the battery, which is this unit here, 200 kilowatt hours, and then out to the motor.
Okay.
And the transmission that's back there.
Yeah, so these are all the pieces we just saw on that buck out there, basically.
That's exactly right.
Just split up and separated, but emulating what you would see on an actual truck.
That's right. And then in our setup, we have hydrogen that comes from the station.
Okay.
That's out back.
Yep.
So we never have to run out of hydrogen, basically.
Nice.
And then the exhaust go out this pipe. So when we're running, you see, you know, some kind of white vapor coming out the front of our building. Coming back further, here we have the motor system. So this is our DC side, goes to the inverter and runs the AC, three-phase AC for the motor. And then we have a 4-speed transmission that in our case, instead of spinning the wheels of a truck, we're spinning this dyno, which is rated to 1.2 megawatts of power.
Nice.
So that converts to about 1,600 horsepower.
Yep.
And it's also rated to about 14,000 Newton meter of torque. So very, very powerful machine. We kind of oversized it because we expect to have other projects in the future.
Future proofing,
And so we're not going to build one of these every year.
Yeah.
So that way we have, you know, room to grow.
And this is the motor used on the same truck out there?
Exactly the same one, yeah.
And what can you tell me about the motor itself? I mean, as far as power and...
So the motor is rated to 350 kilowatts of continuous power, and can go up to 410 as peak power, but not continuously whole. And then we paired that to a 4-speed transmission. So you will see when you ride the truck, it has a tremendous torque.
Yeah.
It takes off very quickly. So it's a very good driving experience, actually, for truck drivers. They really like it.
Okay.
So this is one of the good selling points. Very quiet also compared to diesel.
All right, so we are walking into the sports bar for engineers.
So this is our control area. So these different screens allows us to run the unit, collect data, run the facility, and then the cameras, you know, we can see what's going on inside when we're testing.
Nice. Yeah, this would be a fun job.
It is, yes, very blessed.